Let f of x be equal to the integral from 0 to 1 of xt squared dt, and g of x equal the integral from 0 to x of t squared dt. Let a be greater than 0. Which of the following statements is true? G of f of a is always bigger than f of g of a. Okay, we have a whole bunch of statements. I don't like the wording of option 3. They are always equal. It's not clear what they is referring to, but I'm going to assume that it's referring to the values of g of f of a and f of g of a. So, you know, my first thought here was to try and geometrically argue which of these things is greater than or less than or whatever. But I'm thinking, why don't we just explicitly compute f of x and g of x? These are simple enough integrals that we can write out exactly what they are, and then we could compute these compositions directly with each other. I think that's what I'll do, because it should be, you know, once we have an expression for f of g of a and g of f of a, the correct statement we have here should be pretty easy to figure out. So we'll start with f of x, which is equal to the integral from 0 to 1 of x t squared dt. So this is x squared integral 0 to 1 of t squared dt. And so that's x squared over 3. And g of x is equal to the integral from 0 to x of t squared dt, which is also equal to, sorry, this is equal to x, is it x cubed over 3? Well, let's just work it out like this. This is equal to t cubed over 3 evaluated at 0 and x, so that's x cubed over 3. Yeah, okay, so f of x is x squared over 3, and g of x is equal to x cubed over 3. Okay, so f of g of x is x cubed over 3 squared divided by 3. So this gives x to the 6 over 27. And g of f of x, well, this is x squared over 3, this whole thing cubed divided by 3. So that gives x to the 6 over 81. Okay. So a is greater than 0. So, you know, this one is, as long as this thing is positive, this is always bigger than this, right? So I have f of g of a is greater than g of f of a, which is option B. Hope I did all the algebra and arithmetic and all that correctly. Let me check briefly that I did the integrals the right way. Okay, the integral from 0 to 1 of t squared dt, that's equal to 1 over 3. So I've got x squared over 3. This integral is x cubed over 3. Great. Okay, let's do the compositions here. So g of x is x cubed over 3. I take that, sub it into here, so I square it. I get x to the 6 over 9. And then that, okay, great. And here, again, I have x to the 6 over 27. And then divide again by 3 gives 81. Right, okay. So not much to this one, really. But yeah, I think the way to go on this is probably just to evaluate these two integrals explicitly so you have a simple expression for both f and g, and then go ahead and do the two evaluations of the functions in each order, again, just to get an explicit expression for both of these things. Yeah, but if I have more to say about this one later, I'll write it down in the description. Thanks for watching.